With the rapid development of robotics technology, Rus robot operating system has become one of the hottest topics in the global developer community. With better cross-platform features, abundant software package resources and unified development framework, Rus become the preferred platform for robot development. Last year, the Chinese Society of Automation teamed up with event organizers to launch the Rus Smart Car competition. Rus solutions have been widely used in products such as unmanned vehicles, service robots, and industrial automation. However, the cost of traditional Rus on development boards is relatively high. Users cannot develop Rus robots on some low-cost, low-power MCU, which to a certain extent limits students' learn and practical application of Rus robots. How can realize Rus robot applications on low-cost MCU such as Arduino, STM32, and ESP32? MicroROS is a good choice. It is an embedded version of Rus 2 specifically designed to run in embedded systems to support real-time control and communication of robots and embedded devices. The goal of MicroROS is to extend Rus 2 to resource-constrained embedded platforms. This means that we can learn and apply Rus robots on Arduino, STM32, ESP32, and other microcontrollers to realize classic Rus functions such as radar mapping, navigation and positioning. As a lightweight and efficient embedded Rus version, MicroROS has the following features. Support Rus main concepts. MicroROS brings all the core functions in Rus 2 to the microcontroller, MCU, including nodes, publish and subscribe message mechanisms, client and service calls, node graphs, and life cycle management. Integration with Rus 2. The MicroROS agent can seamlessly connect MicroROS nodes on microcontrollers, MCUs, and Rus 2 systems. User can use Rus 2 tools and APIs to easily access and manage MicroROS nodes, just like operating ordinary Rus nodes. Communications and middleware. MicroROS can communicate with other Rus 2 systems. It supports serial port, Wi-Fi UDP, Ethernet, and other communication methods. Real-time performance. MicroROS supports real-time requirements and ensures system reliability and response speed. Embedded system support. It can adapt to a variety of microcontroller architectures, such as ESP32, Arduino, Raspberry Pi Pico, STM32, etc. Cost effectiveness. Compared with traditional Rus robots, MicroROS robots do not need to perform a large amount of data processing operations while maintaining a smaller size. They also have lower energy consumption and a more compact size. In the field of traditional Rus robots, if the robot device wants to access the Rus development environment, it needs at least a computer, a development board that can run Rus, Raspberry Pi or Jetson Nano, and a Rus expansion board. Then, connect it to a peripheral driver board. Control the robot. The product control process is long and costly, and real-time performance cannot be guaranteed. With MicroROS, you only need a computer and a MicroROS driver board, which reduces intermediate communication losses, makes the product smaller and more convenient, and reduces mass production costs. The core advantage of MicroROS is that it can fully utilize the Rus 2 ecosystem and run on various MCU, enabling the integration of embedded devices and complex robotic systems. Through such a software and hardware co-design strategy, learning efficiency can be greatly improved and learning costs reduced. Currently, there are already products on the market equipped with MicroROS technology, such as Yabum MicroROS Robot, which uses the MicroROS platform to communicate with PC virtual machines through Wi-Fi UDP mode to implement Rus applications. It is also equipped with MS200 LiDAR, metal motor with encoder and full vehicle aluminum alloy bracket. MicroROS Robot can not only be used to learn the Rus 2 robot operating system, but also provides hardware driver tutorials to help developers fully master Rus 2 robot development.